So, good morning. Am I audible? Hello. Am I audible?
Yes, sir.
Yes, sir.
Okay. In the last class, we have discussed how to calculate the center of a right angle triangle and also semicircle and sector of a circle and also the quarter circle by the method of integration. Now, today we shall discuss some of the numerical problems on centroid. So now let us take the first problem. Now here determine the location of centroid of the L-shaped area shown in figure. Now here you have a L-shaped area. Here you have an L-shaped area and the dimensions are given here. So the width of this is 140 millimeters and this height is 20 millimeters. And the total height from this point to this point, this side it is 150 millimeters and the width is 20 millimeters. Now this is the given L-shaped figure. So you need to find the centroid. Centroid means the point G, correct? Here the figure shows this is the point of the geometric center of this L-shaped figure and through which the two axes passes, that is X naught and Y naught axis. So this point we have to find. We have to locate the center of the given L-shaped figure. Now first start with, first select the reference axis about which you are going to find locate the centroidal or coordinate distances. So select the reference axis towards the extreme left of the figure and the bottommost part of the figure. Now you can see here the x-axis has been chosen at the bottommost part of the figure and y-axis is chosen to the extreme left of the figure. So these are the two coordinate axes about which you are going to find the coordinate distances. Now you have to divide this figure into two parts. You have to divide this into two parts. So you can see here you have a dotted line. So this whole part becomes part 1 and the bottommost part, it is part 2. So you can divide in your own convenient way. So either you can have this dotted line here like this and you can consider this whole figure as 1 and the remaining figure as 2. So in this case, so here the figure has been divided into two parts. So this is part 1 and this is part 2. So now we need to locate the corresponding centroid of these individual figures. You can see here G1 and G2. So we have to locate the centroid of these individual figures G1 and G2. Then we can find the coordinate distances, that is X bar. X bar is always measured with respect to y-axis and y bar is always measured with respect to x-axis. Now you can see here x bar is measured with respect to y-axis and this is the x bar distance and y bar is measured with respect to y-axis. Now split the area into two parts as shown in figure. Now you calculate the areas of these individual figures. Now let us take this one. So the area of this figure is 20 into 130 because you have to deduct this height. This height is 20 mm. So from here to here it is 150. So you need to deduct this 20 mm. So the remaining is 150 minus 20 is 130. 130 into 20. You can see here A1 is 130 into 20. So the unit for area is millimeter square. Now the figure 2 you have to find the area. So area is 140. This is the width and height is 20 millimeters. So 140 into 20, that is millimeter square, whatever the value you get. Now, once you find the areas of this individual figure, first step is you need to select the reference axis towards the extreme left and bottommost portion of the figure. Then you divide the figure into two parts. That is part 1 and part 2. Then you calculate the areas of these individual figures A1 and A2, that is 130 into 20 and 140 into 20. So it works out with 2600 millimeters square and this works out with 2800 millimeters square. Now we have to find the X bar, that is X coordinate distance and also the Y coordinate distance. So now we know the equation that X bar is equal to A1 X1 plus A2 X2 plus A3 X3 plus an xn divided by the whole area. So similarly, y bar is a1 y1, a2 y2, a3 y3 plus a1 dash 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 an yn divided by the area, total area. Now, total area of this figure is sigma a1 plus a2. So the total area is sigma a1 plus a2. Now, we have to locate the x bar. X bar is always measured with respect to y-axis. So this is the distance required. X bar, it is measured with respect to y-axis. Now, so x bar is nothing but a1 x1 plus a2 x2. So in our case, we have this a1, but we want the x1. X1 is measured with respect to y-axis. So x1 is measured with respect to y-axis. Now this is the point. That is x1. You can see here, this is x1. So which is nothing but half of this, correct? So you have to measure with respect to y-axis. So here, this width is 20. So half of this is 20 divided by 2, that is 10 millimeters. 10 millimeters. Now you can see here, x1 is 10 millimeters. Now you can see here, x1 is this distance. That is from this point to this point. So here, the total width is 20 millimeters. So hence, x1 will be 10 millimeters. So similarly, you have to find this value, x2. Now you can see here, from this point. Hello? Pardon? Nikita A. So mute ಮಾಡ್ಕೊಳ್ಳಿ. Nikita A. Mute ಮಾಡ್ಕೊಳ್ಳಿ. Or you have any doubts, Nikita? Nikita A. Can you hear me? Okay. So now you have found x1. X1 is nothing but it is this distance x1, and x2 is from this point to center of this figure. Hello, Nikita. So now x2 is from this point to this center of this figure. You can see here from this point to this point. So this width is 140 millimeters. So half of this will be your x2. That is 140 divided by 2. You can see here it is 70 millimeters. It is 70 millimeters. So now you know A1, you know A2, you know x1, you know x2, and you know A, capital A, that is nothing but sigma A1 plus A2. So now we know that equation, that is x bar. X bar is nothing but A1 x1 plus A2 x2 divided by A, that is nothing but sigma A1 plus A2. So A1 is 130 into 20 multiplied by x1. X1 is to 10 millimeters. Similarly, A2 is 140 into 20 multiplied by x2 is 70. So this whole divided by A1 plus A2. So it works out to be 41.1 millimeters. Now you can see here x bar value is, that is from this point to this point, the x bar value is 41.1 millimeters. So similarly, we want to find this y bar. Y bar is always measured with respect to x-axis. So similarly, we want the coordinate distances, that is y1 and y2. Now, y1 is measured from this point to this point. So this is y1, and y2 is half of this height. So this is y2 in our case, and this is y1. Now let us find y1. So now this height is how much? 130 millimeters, because this whole height is 150 millimeters. So we want the distance from this point to this point. So y1 is, you can see here, y coordinate distances is 20. We have to add this 20 plus 130 divided by 2. So that means y1 is measured with respect to x-axis. So from this point to this height. So I want this height y1. So y1 is, so this height is 20 millimeters. and the remaining height is 130 millimeters. So 130 divided by 2, from this point to this point it is 130 divided by 2, it works out to be 65 millimeters, correct? 130 divided by 2 is 65 millimeters plus 20. You have to add this 20 because we are measuring y1 with respect to x-axis. Now you can see here y1 value is 20 plus 130 divided by 2, so it works out to be 85 millimeters. So next y2 is nothing but from this point, from the x-axis, this height you want. This height is y2, so which is nothing but half of this, that is 20 divided by 2. So from this point to this point it is 10 millimeters. So now you can see here y2 is 10 millimeters. So we have found x1, x2, y1, y2, and we know a1, a2. So thereby we can calculate x bar. X bar is a1, x1 plus a2, x2 divided by a1 plus a2. So it works out to be 41.1 millimeters. So similarly, we know the y coordinate of the area, that is y1 is 85 millimeters and y2 is 10 millimeters. So y bar is a1 y1 plus a2 y2 divided by a1 plus a2. So it works out to be 46.1 millimeters. So now you can see here the centroidal distance, the coordinate distances of this given L-shaped figure is, it is at a distance, x bar is at a distance 41.1 millimeters and y bar is at a distance 46.1 millimeters. So this is the geometric center of the given L-shaped figure. So is it clear? Shall I move on to the next problem? Hello, anyone having any doubts with this? How to find x1, x2 and y1, y2? Is it clear? Hello? Shall I move on to the next problem? ಹೇಳ್ತಾ ಇದೆಯಾ ನಾನು ಮಾತಾಡೋದು?
Explain on, sir.
Yes, sir. You have any doubts with this problem? How to divide the figure? So or else you can also divide the figure like this also. Like this whole becomes 1 and this remaining part becomes 2. So next problem we shall take up. Now here you have find the location of centroid of the area shown in figure 8.3. So this is the given figure. So it is in I section. It is in the form of I. Correct? It's an I section. So this length is 100 millimeters and this height is 10 millimeters and this length is 160 millimeters and this height is 10 millimeters, and from this point to this point it is 180 millimeters. So this is in the shape of an I section. So now here you have to find the centroid, that is the geometric center of this figure, G. So G stands for the geometric center of the figure through which the x0 and y0 axis pass. Through which the x0 and the y0 axis pass. So this G, that is the geometric center, that is x bar is measured with respect to y axis and y bar is measured with respect to x axis. Now, first and foremost thing is you have to select the reference axis towards the extreme left of the figure, given figure. So here, this is the extreme left. You have to select the y axis and you have to select the x axis which touches the bottommost part of the figure. So this is your x axis. Now, the given figure is divided into 3 parts. That is, the upper one is part 1 and the middle one is part 2 and the lower one is part 3. So we have divided the figure into 3 parts. Now, if you look at this figure, the figure is symmetrical about y-axis, correct? The figure is symmetrical about y-axis because on both sides you have the mirror image, correct? So hence, since the figure is symmetrical about y-axis, obviously x bar is 18 millimeters because this whole distance is how much? 60 millimeters. So now you can see here y0 axis passes through the center of this figure. So this figure is symmetrical about y-axis. Hence, directly we can get the value of x bar is equal to 80 millimeters. Or else to begin with, you can calculate x1, x2, x3, and then you can find a1, a2, a3. Then you can use that equation x bar is equal to a1, x1, a2, x2, a3, x3 divided by a1 plus a2, a3. Finally, you will get the same answer. That is x bar is equal to 80 millimeters. So, because if you have that knowledge of selecting whether the figure is symmetrical about x-axis or y-axis, you can avoid one step. Directly you can get the value of x bar, or else you have to find x1, x2, x3, then a1, a2, a3, then finally you have to use that equation to find x bar. So only thing is you have to look out the axis of symmetry. So this figure, given figure is symmetrical about y-axis, hence directly x bar will be equal to 80 millimeters. Now, first, what we have to do is first select the reference axis which touches the extreme left of the figure and bottommost part of the figure. Then divide the figure into three parts. Divide the figure into three parts. Now you calculate the areas of these individual figures. So A1 is equal to 100 into 10. 100 into 10. So it is 1000 millimeters square. And A2 is this one, center figure. So this height is given 180 millimeters. And this thickness is also given, that is 10 millimeters. Now you can see this two arrows, so which indicates that the thickness of this is 10 millimeters, or the width of this figure 2 is 10 millimeters, and height is 180 millimeters. So A2 is 10 into 180, that is 1800 millimeters square. So similarly, A3 is 160, the height is 10 millimeters. So it works out to be 1600 millimeters square. Now, so if you find difficulty in selecting whether the given figure is symmetrical about x-axis or y-axis, so now we shall calculate x1, x2, x3, and then we shall find x bar. So whether it matches with this one. Now, x1 is measured from this point to this point. Correct? X1 is the coordinate distance from y-axis to the center of this figure, and x2 is the coordinate distance from this y-axis to center of this figure, and x3 is the coordinate distance from this point to center of this figure. Now here x1. So now, so this from this point to this point, it is how much? It is 50 millimeters. So this point to this point, because half of this is 100, so the remaining is 50. Now you can see here, this is 160 millimeters and this is 100 millimeters. On either side, how much is left? That is 60 millimeters. 60 millimeters means this side it is 30, this side is 30, and this distance is how much? 30 millimeters. So x1 is 30 plus 100 divided by 2. That is 30 plus 50. So it works out to be 80 millimeters. 80 millimeters. So x1 is 30 plus half of this, that is 100 by 2, that is 80 millimeters. So similarly, x2 from this point to this point, correct? So now this is the center, again this is the center, so this is 50, correct? 50 plus 30, so this distance is how much? 80 millimeters. So x1 is also 80 millimeters, x2 is also 80 millimeters, and x3 is also half of this, 160 divided by 2, so that is g3. So this is your x3. So x1 is 80 millimeters, x2 is 80 millimeters, x3 is also 80 millimeters. Now you know the equation, x bar is equal to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. So then you will get the same answer. That is x bar is equal to 80 millimeters. You can cross check. So since you can avoid that one step, so if you find the axis of symmetry, so here it is symmetrical about y-axis, hence directly you will get the value of x bar as 80 millimeters. Now we have to find the y bar. So it is not symmetrical about x-axis. The figure is not symmetrical about x-axis, hence we need to find the value of y bar. So now we have to find the values of y1, y2 and y3. So y1 is this height from the center of this figure to x-axis. So this height we have to find from the center of this figure to x-axis, that is 10 plus 180. So from this point to this point, how much it is? 10 plus 180, 190 plus half of this. It is 10 divided by 2, 5 millimeters. So hence y1 is 10 plus 180 plus half of this. That is 180 plus 10 is 190. So 195 millimeters. So y1 is from this point to x-axis. It is 5 plus 180 plus 10. So it works out to be 195 millimeters. So next y2. So y2 is from this point to x-axis. From this point to x-axis. So y2 is 10 plus half of this height. So this is 180 millimeters. So half of which is 90 millimeters. So 90 plus 10. So y2 is 100 millimeters. 100 millimeters. Next y3 is from this point to center of this figure. That is, this height is 10 millimeters. So from this point to center of this figure, it is 10 by 2. It is 5 millimeters. So y1 is 195 millimeters, y2 is 100 millimeters, and y3 is 5 millimeters. Now let us check. Now here you can see here the given figure is symmetrical about vertical axis, y-axis passing through the center, because the shape and the area of the figures on both sides of the y-axis are same. That is, you have a mirror image. So that is known as the axis of symmetry. Now let us check y1. Now you can see here y1 is 10 plus 180 plus half of the upper part figure, upper portion, it is 195 millimeters, and y2 is 10 plus 180 divided by 2, so it works out to be 100 millimeters, and similarly y3 is 10 divided by 2, that is 5 millimeters. So hence you can calculate the value of y bar, a1 y1 plus a2 y2 plus a3 y3, that whole divided by a1 plus a2 plus a3. So thereby we'll get the y bar distance as 87 millimeters. You can see here from this point to this point. So this is the geometric center of the figure from this point to this x-axis. So y bar distance is 87 millimeters, and from this y-axis to the geometric center of this figure, it is x bar is 80 millimeters, because the figure is symmetrical about y-axis. So any doubts with this problem? Hello? Anyone having any doubts with this problem, how to calculate the values of y1, y2, y3? Is it clear? Shall we move on to the next one? Hello?
Yes, sir.
Okay, is it clear?
Yes, sir.
Okay, fine. So now, so far we have discussed simple figures wherein you have only rectangle shape figures, rectangular shape figure. So that means in the first problem, you have two rectangles. And in the second figure, you have three rectangles. This is one rectangle. So this is one rectangle. And this is one. So now let us discuss the next problem. So now here you have two semicircles. So this is one semicircle and this is the other semicircle. So this one is the other. Here you have two semicircles. So you have to find the geometric center of this given figure. So here you have one semicircle, the radius of which is 60 millimeters, and you have the second semicircle. So this is figure 2. So the radius of which is half of this, that is 30 millimeters. So this semicircle, the radius is 30 millimeters, and the bigger one is the radius is 60 millimeters. So now you can see here G1. G1 is nothing but the geometric center of this first semicircle, and G2 is the centroid of the second semicircle, second figure. And this G is the geometric center of these two semicircles. So here, through which the x0 and y0 axis passes. So this G, that is x bar and y bar values, you have to calculate x bar and y bar value. So now here we have two semicircles, and we have already discussed in the previous class how to locate the centroid of a semicircle by the method of integration. So we have found the centroid of the semicircle by the method of integration, that is x bar is equal to 4r by 3 pi. When the semicircle is symmetrical about x-axis, the centroidal distance will be, that is x bar will be 4r by 3 pi. And if the semicircle is symmetrical about y-axis, then we need to find y bar. Y bar is, that is also equal to 4r by 3 pi. So we have already discussed in the previous class how to locate the centroid of a semicircle by the method of integration. Now this is the given problem. So where you have two semicircles, one is having a radius of 60 millimeters, the other one is having a radius of 30 millimeters. Now, first what you have to do is, first you select the reference axis towards the extreme which touches the extreme left portion of the figure and also the bottommost portion of the figure. So this is the x-axis and this is the y-axis we have selected. Next, the given figure has to be divided into two parts. That is, figure 1 is the bigger semicircle and figure 2 is the smaller one. Now once you divide these two figures, so next you have to find the areas of the corresponding individual figures. So A1 is pi r square, pi r1 square by 2, because this is the figure 1. So pi r1 square by 2, that is pi into the radius is 60 square by 2. And similarly A2 is pi r2 square by 2. So here the radius is the half of this, that is 30 millimeters. So pi into 30 square divided by 2. So these are the corresponding areas of figure A1 and A2. So you can find sigma A. Sigma A is nothing but A1 plus A2. So it works out to be 7.07 into 10 power 3 millimeters square. So the units are very important. As soon as you arrive at the answer, you have to write the corresponding units. So area, the unit of area is millimeter square. Now we have to find the values of x1. So this is the geometric center of this figure 1. So this is your x1, correct? And from this point to this point, this is your x2. And similarly, this is your y1. The height is y1, and from this point to this point, it is y2. So the time is running out. So we should take up this problem in the next class. So any doubts with the previous two problems? Hello? So we shall work out numerical, so many numerical problems containing so many composite figures in the subsequent classes. So to begin with, you have to please go through these two problems, whatever the problems that we have discussed today. Then tomorrow we shall take up this problem. So anyway, I think another 5 minutes time we have. Anyway, we shall try to find out the values of x1 and x2. Now, x1 is from this point to this point. So this horizontal distance I need, correct? x1. Now, so with respect to y-axis, the centroidal distance of the semicircle from this point to this point, it is 4r by 3 pi. 4r by 3 pi. Now you can see here the given figure is symmetrical about x-axis, correct? The given figure is this semicircle. This semicircle is symmetrical about x-axis. Now the centroidal distance of the semicircle with respect to this axis, this distance, this height is 4r by 3 pi. So now I want this distance, this x1, from y-axis to this point. So from this point to this point, this is the radius of the semicircle. Radius of the semicircle, that is 60 millimeters. Now I want this distance. This is x1. So x1 is 60 minus 4r by 3 pi. So I have to deduct this because I want the distance from this point to this point. So this distance is 60. So I want this distance. So this distance, this height is 4r by 3 pi. That is the centroid of the semicircle with respect to base. It is 4r by 3 pi. So x1 is 60 minus 4r by 3 pi. 60 minus 4r by 3 pi. Now you can see here x1. x1 is r1 minus 4r1 by 3 pi. So r1 is how much? This is r1, 60 minus of this height, that is 4r by 3 pi. So it is r1 minus 4r1 by 3 pi. So 60 minus 4 into 60 by 3 pi. Now similarly, x2 is measured from this point to this point. Correct? X2 is measured from this point to this point. Now if you consider this semicircle, this is the centroidal distance from base to this point. This is 4r by 3 pi. This distance is 4r by 3 pi. I need the x2 values from this point to this point, from y-axis to this point, that is g2. This is your x2. So x2 is 60. This is the radius of the circle. 60 plus 4r by 3 pi. So here it is 60 minus 4r by 3 pi. So when you consider semicircle 2, that is 60 plus this distance, that is 4r by 3 pi. So this is 4r by 3 pi. So x2 is, you can see here, r1 plus 4r2 by 3 pi, that is 60 plus 4 into 30 is the radius divided by 3 pi. So we have found the values of x1 and x2. Now we want the values of y1 and y2. So from this point to this point it is y2, and from this point to this point it is y1. So y1 is nothing but it is the half of the radius of this semicircle. Y1 is the radius of this semicircle, and y2 is the radius of this semicircle, because you are measuring the height from with respect to x-axis. Now you can see here y1 and y2. So y1 is nothing but the radius of this semicircle, because this is the semicircle which is symmetrical about x-axis. Hence y1 is nothing but the radius of the circle. And if you consider this semicircle, it is symmetrical about x-axis. Hence y2 is nothing but the radius of this semicircle. So hence you can see the y1 and y2 values are 60 millimeters and y2 is 30 millimeters. So we know x1, x2, y1, y2, and also we know the equation. This x bar is equal to a1 x1 plus a2 x2 divided by a1 plus a2. So x bar works out to be 42.2 millimeters and y bar works out to be 54 millimeters. You can see the distances. So y bar is 54 millimeters and x bar works out to be 42.2 millimeters. So again we shall discuss this problem in the next class. So the time is running out. So please mark your attendance in the chat box. I'll be ending this session. I think already marked your attendance in the chat box. So anyway, thank you very much. So we shall meet on Saturday at 10:45. Till then, have a nice day. Stay safe. Thank you.